basics on positioning ourselves and our research and what we are able to do and what types of questions we could address and all that yesterday. Today we'll again do things that relate to different types of data collection methods and are important for all of these. But in the first part become a bit more technical, and the latter part become maybe a bit more, not philosophical, but at least talk about norms and ethics. So in this first hour I want to talk about sampling. And sampling, when we hear sampling, many of us think about surveys and big samples of people. But sampling is basically, it's related to surveys, it's related to experiments. Even if you do a content analysis, you sample. You know, there are news media out there, there's papers out there are social media accounts out there, and from those you sample and only look at the subsection of those. And content analysis, where people are sometimes or often very pragmatic and just picking certain things and say this is what I'm working with, without really reflecting very thoroughly on how that sampling strategy could influence their results. So in that sense, sampling again sounds a bit survey typish, but is much more relevant beyond surveys as well. So what we do today is sampling theory and types of samples, and I also added 10 minutes about the use of primary versus secondary data, because yesterday I sensed that, you know, some of you will try to collect their own data, but some of you will also be working with other data sources, data that other people gathered, and there's something to watch out there that I just wanted to highlight in this first hour as well. And then we'll do some interactive stuff again, and I want you basically to take your research questions that you tried to formulate yesterday in the groups and think about how you would go about sampling in order to address those research questions. What would be the most appropriate ways? Is it possible to sample the way you'd like to sample? And so on and so forth. So that's what we'll try to do in the tutorial today, and then in the lecture after that we'll talk about research ethics, again an important topic for all types of different quantitative but also qualitative approaches, and an issue that becomes increasingly important in the social science research world. Literature is this, so you see the first two articles are more about sampling and try to give a bit of an overview of some of the sampling strategies, and then the second two articles are about research ethics, and are going a bit deeper into some issues that we don't fully address today. So the very interesting issue of what happens when you do research in social media, which is done a lot these days, but it's very easy to identify people when you do research on social media. So how do we go about that? And the other one, the important issue of informed consent forms and how to formulate them. That's something we'll also talk about in the lecture. So, questions about that? Anything we should be doing that I forgot to say? Again, you interrupt me anytime if you want to interrupt me and if you have questions, right? Thanks. Sampling is interesting because sampling basically, the idea of sampling is that we take a smaller bit of something bigger and we can still say something about that bigger, although we only look at the smaller bit. That's what's quite fascinating about sampling, and that allegedly that works quite well. And indeed, if you look at a lot of research, it seems to work quite well. We also know a lot of examples where it's going utterly wrong, and I'm not sure about this country, but in many countries that I follow politics, and pre-election polls are far off what the election results will be in the end. So there's a mismatch between the allegedly representative samples that pollsters use a couple of days before the election and the results that then come out of an election, for instance. That's the popular examples when we see that sampling might also go wrong, and we'll try to get a bit more understanding of when or why that might go wrong in certain cases. But we'll also look a bit about the theory or the mathematics, and it's not going to be strongly mathematical, but there's no formulas, but mathematics behind why sampling actually does work if you sample correctly, if you sample well. Let's maybe, before we really dive into sampling, consider why we sample. And again, yesterday we talked about that we collect quantitative data because we want to conduct statistical analysis with these data. So we want to compute something, estimate something with these data, and that's why we need numbers. And the two main things that we do in the social sciences, it's not all that we do, but the two main things that we do in the social sciences are descriptive statistics and inferential statistics. Right? So in descriptive statistics, we describe our sample basically. What is the frequency distribution of something in the sample? So what's the frequency of men and women, or education, different types of education? What is the sample mean, for instance? So what's the mean income of everyone in the sample? Standard deviations, so how strongly are the people spreading around this mean? If there's income, this is the mean of the income, and is there everyone very close to this mean, like we often find in Scandinavian countries, no huge income differences, for instance? Or is the variation around this mean very big? Like I could imagine is the case in this country. A lot of poor people, some rich people, there's a mean somewhere here, but it spreads around the mean quite strongly. So that's stuff that we can look at for our sample. And then we can only say something about our sample. We describe our sample. That's something you would often see when you read method section of quantitative papers. You know, we collected a sample, our sample includes this many men, this many women, it's educated in this way, blah, blah, blah. So describe some of the socio-demographic variables that you have collected for your sample. And then in inferential statistics, we try to go a step further, and we use the sample to try to draw conclusions about the population. So to say something about what the frequency distribution, mean, standard deviation in the entire population might be based on the data in our sample. We infer this information from the sample about the population, inferential statistics. This we could do with any sample. Right? Doesn't matter how you collect your sample, what your sample looks like, you can describe any sample. This we can only do when our sample has been drawn, has been collected according to certain characteristics. And usually, and that's what will sound familiar to everyone, this is a random kind of sample. And we'll get into why that actually works. Some basics in terms of terminology. There's the population, there's the sample, as I already mentioned just before. The population includes all members or objects of a group that the researcher is interested in. So if you want to say something about the Indian the people in India, then it's the Indian population, everyone in this country who would be the population. If you want to say something about the newspaper coverage in the Hindu Times in the year 2013, then every article that the Hindu Times in 2013 published is your population. You need to define your population. And that also defines, when you draw a sample from that population, defines what you can say about which population you can actually talk when you draw your sample. You could say, I want to say something about the students at this university. Then everyone studying at this university is your population. Right? Again, it's important because often one reads population, one thinks it's all people in the country or so. But populations need to be defined and can differ in size very much or in type and so on and so forth. The sample then is a part of that population. And ideally this sample retains all the characteristics of the population. So I'm not sure what the distribution of male and female students at this university is. But let's say it's 60-40, so it's 60 female, 40 male. You know, that's the population of students. When I draw my sample of 200 people, I ideally want the same gender distribution in that sample. If I draw a sample of the Indian population, I want as many poor, as many rich people, as many men, as many women, as many well-educated, as many non-educated in the sample as there are in the real population. Because only if that's the case we can make inferences, use inferential statistics to say something about the population based on our sample. Why do we sample at all? It sounds a bit complicated to do. Yes, but we do that because none of you can do a survey among the Indian population, I guess. None of you can investigate news coverage in 10 newspapers for a 50-year period, or maybe for a 1-year period. It would be very hard to get a survey response from every student at this university. We might eventually get there, but it would be very hard and very time-consuming and labor-consuming. So sampling is making things efficient. It's doable if you sample. The research becomes doable if you sample, and if you don't sample, you are often stuck with not getting data about the entire population. So again, you've got your population, you draw a sample, and again, if some characteristic in your population is, in this case, normally distributed, ideally you find a normal distribution of that characteristic in your sample as well. Yeah. More about normal distributions in a couple of minutes. Becomes a bit more complicated than this sounded. Because the population is something you can define, that you can empirically target. There's a universe out there that you would ideally speak about. So let's come back to the Indian population maybe. I don't know too much about this country, but I assume there's people living in the country that are not registered somewhere. Don't have a record about every person in this country. Still, you want to say something about the Indian population. So in that case, the Indian population would be the universe of people that you would talk about. But you can only draw a sample of the people that have some record somewhere, that you can actually empirically see somewhere out there. And then from that population, you draw a sample. So that's the 1,000 people you ideally talk to. Yeah? And then the problem is that some of those 1,000 people won't talk to you. So you again lose a few people. And that's not unsubstantial. And we'll talk a bit more about response rates tomorrow when we talk about surveys. But this, often when we do telephone surveys, we try to reach an entire sample, but we only get 30% of the sample we target. So this loss can be quite substantial. And still we hope that our original sample, the final sample that we collect is good enough. And again, we'll talk about response rates tomorrow, is good enough to say something about the population. Questions? Sometimes there's no difference here. Like when it comes again to the newspaper articles in the Hindu Times of 2013, it will be fairly easy, I guess, to get those articles and to make sure that you've got all your articles in the population sample. But sometimes it's not. So, again, population, select a sample allows generalization about population, and you want the sample to be structurally similar to the population, and that goes for anything, by the way. It doesn't only go for social demographics like gender, age, education. That goes for party preferences, that goes for emotional states, that goes for anything you could think of. Anything you could measure, could be interested in a person or a news article, should be the same structurally in the sample and in the population. Just quickly, notation stuff. So the population is usually notated as large N, capital N, and the sample is small n. Though if you look at articles, you see that not everyone adheres to that notation. By and large, there's two classes of samples that we use in the social sciences. That's probability samples and it's non-probability samples. That's the big differentiation between what we do in social science research. And you see each of these then is split up into different types of more specific strategies. So the non-probability methods are splitting up in convenience samples, in judgment samples, in quota samples, in purposes samples, and so on and so forth. The probability methods split up into simple random sampling, into different sorts of stratified sampling, into different sorts of clustered sampling, and we'll hear a bit more about that later on. The important difference is that here there's always some randomness involved in selecting objects from the population to your sample, whereas here that's not the case. There's also some randomness involved here, but it's not a true, real randomness. So we'll come to that in a second. But if I sample students from this university and I do so by walking around with a questionnaire and asking people to fill in the questionnaire, it feels like quite random what I do. But it's effectively not, because if I only do it in the afternoons, there will be people that are only on the streets in the afternoons, and only other people will be on the streets only in the morning, for instance. So there's always some sort of structural bias and non-probability samples that ideally you don't have in probability samples, because you work with true randomness. This is another one of those pictures. You see the random samples don't go much further. They actually do, but in a combination of all of those don't go much further than this. And then in the non-random group, this purposive sampling can split up into endless different cases. What we often do, what my students often do, is snowball or chain sampling. So they send a survey to their Facebook friends and ask them to fill in the survey, but also to forward it to their Facebook friends, and to their Facebook friends, and to their Facebook friends. You know, you throw snowballs or chains. You could sample extreme or very deviant cases purposely because you're interested in just those cases. So there's a lot of different ways here, which would always, not always, many of those would reflect different research interests. So you've got a research question about extreme cases, about people. I mean, I just reviewed a manuscript about Orthodox Jews in the United States. And of course, you know, if that's, then it's hard to find a database and to draw random samples. So you would go for rather purposive sampling. Non-probability samples. Just the two big types. So convenience sampling is choosing subjects based on how easy or convenient it is to reach them. That's what we very often do in experiments. You know, when we try to get people into the lab, we either ask the students in our class, which very often happens in psychology. You know, students get credits for participating in experimental research, so for the researcher it's very convenient to get them. If I do a survey of the students at this university and walk around the squares and take questionnaire. That's a very convenient way for me to gather data and to reach the students. Again, it's street interviews. It's any way that you think it is easy to get your respondents without having to go at length in terms of sampling strategies. So convenient sampling, very often used for experimental research. Surveys based on convenient samples often appear very shaky. And you need to have a good reason if you do survey research to use a convenient sample. Or motivate very well why you think convenient sample is appropriate in your case. And sometimes that might be the case. You know, I'm sometimes doing these things with students when it's about concept testing. You know, we want to see whether the questionnaire works or whether certain relationships in the questionnaire can come up or are likely to come up, and we want to test questions and all of that. You know, convenient sampling, no problem, and sometimes that can be a very substantial research interest. But when it comes to say something about bigger populations, it's very hard to do so. Sometimes in content analysis we also use convenient sampling because, hey, newspaper A is available in the library of newspaper B, unfortunately not. So I'd rather go for newspaper A. Or some of the group yesterday said they want to look at newspaper front pages. Why do you look at front pages? Because it's more convenient than going through the entire newspaper? And what does it mean? Yeah. That connects nicely to purposive sampling, because your answer now could be, I look at front pages because they are more important. Hey, then you've got a reason, you've got a purpose why you look at front pages only, or why you want to choose people on certain, you know, you might want to do a survey among female students at this university, or male students at this university. You might be interested in some predefined characteristic. Here, the example, for instance, you're interested in people's perceptions of video games, and you do surveys on websites that review and discuss video games. The problem again, whatever you do in terms of non-probability methods, you're not able to say anything about bigger populations in a very strict sense, because there's no randomness involved. And keep that in mind, because I know I'm talking to a lot of PhD students, you know, and many students come to me with initial ideas and say, I want to do a survey. If you do a non-probability survey, it's not going to get you far, at least in terms of, you know, international publications and so on and so forth. If you want to do a probability survey, it's very hard to do yourself, if not impossible, I'm tempted to say. Or it's going to cost you a lot of money. We talked about costs yesterday. I realized that it was much cheaper in India than it was in Austria, of course, but still, it's a lot of money that you need to get a sample of 1,000 people representative of some population. So consider that when you think about research questions, research strategies. Do I actually have the funds? Do I have the possibilities to go for real probability samples on certain groups? Now the nice thing about probability samples, and I'll get into the theory behind that a bit more in a second, is we know that the more often we draw a random sample, and the bigger that sample is, the closer the distribution of characteristics of that sample is to the distribution of those characteristics in the population. And we can reach that with different types of probability samples, and the most typical one would be the true random sample. So every idea, every member, every object in the population, and again that could be newspaper articles, that could be people, every object in the population has an equal chance to be selected into the sample. And equal chance in this case really means equal chance. So what do I do if I want to sample 20 of you? What would you do if you sample 20 of you? What would be your approach? But how would you go about randomly picking up people? Now I just want a random sample of the 40, 45 of you. I just want a sample of 20 people in this group. Randomly picked. How do I go about doing that?
You can make checks and
sorry?
We can make checks and select 20 people from 45 people.
Yeah, lottery, exactly. So I've got every one of your names on a piece of paper, I've put them all into a hat, and then I pick 20. That's true random. Yeah? I could also say,
for example, if you don't know the serial number of the people, so you can randomly speak any of the serials randomly.
Yeah.
You must not be aware of the number in front of the number. It could be a random.
Yeah, but again, if you give me a list of numbers and you ask me to randomly select, there's going to be a pattern in there.
They should not be in the pattern setting pattern. They should
it's very hard.
Be a name in front of that. So it should be only numbers.
Yeah, but even if I have a piece of paper with 40 numbers on it, and you ask everyone to randomly select 20 numbers, there is a good chance that we will find patterns in what we do. We tend to select numbers with the last digit, where the last digit is the same, or the second digit is the same. It's very, very strange. There's nice research about that. That we have a very hard time being truly random when we select something randomly, allegedly. So drawing from a hat is really nice. I tried these things with closing the eyes and having a pen and pointing to something when I was a student, which I wasn't sure whether that worked well, but that's what you could do. Using dices, I could turn around, point at you, that would be you now, and then start throwing a dice and count every time I throw the dice the next member. So I throw a 3 and then it would be you. And I throw a 5 and it would be you. And I throw a 1 and it would be you. The dice should generate random numbers at least. So that's possibilities to get at randomization. There are tables of random numbers. So if you say, you can find them on the web basically, and those might help you sometimes. And we'll see an example. There are random number generators on the web. So I could assign each of you a number from 1 to 45, and then take a random number generator, and they're based on complicated algorithms that make sure that the numbers